The top 5 GMO producers in the world are the US, Brazil, Argentina, Canada, and India, which you can see in these data from the International Service for the Acquisition of Agribiotech Applications. You'll also notice that the GMO adoption rate for specific crops, the percentage of farmland dedicated to these crops where farmers are growing GMO varieties of them, is quite high in these countries. For example, 95% of soybean, corn, and canola are GMOs in the United States. And the data get really interesting when you look more closely at what exactly the most widely produced GMO crops actually are. To some extent, this aligns with which crops are most widely produced in general, but interestingly, you don't see, say, rice or wheat on here, which are also very widely produced. Why is this? Well, it could be partly because of what countries exactly dominate GMO production. For example, the US, the leading GMO producer, doesn't produce that much rice in general. But it's also the case that most GMOs are produced for large-scale agriculture, and that means that they are generally industrial crop varieties, which you see here. They aren't generally being produced for philanthropic means, like enhancing food's nutritional quality in developing countries. Speaking of that, it's also important to understand what specific types of modifications we're looking at here. For context, most GMOs fall into one of two categories. One, herbicide-tolerant, or HT GMOs, which are engineered to withstand a particular herbicide and allow farmers to extensively spray their fields and eliminate weeds. And two, insect-resistant, or IR GMOs, engineered to be toxic to insects, acting as essentially a built-in pesticide. And many GMOs actually have both an herbicide-tolerant and an insect-resistant trait. Here's the USDA's data on GMO varieties in the United States. You'll see that almost all of the soybean, cotton, and corn in the US is HT, and that the vast majority of cotton and corn have the BT trait, which is a form of insect resistance. Now, an important side note is that I haven't been talking about gene-edited foods in this video. I've been talking about GMOs, and if you aren't familiar with the difference between those two, check out my previous video, which explains it. The reason for this is that gene editing is a much more recent development than traditional modification. The development and use of gene editing technologies really began in 2012 with the harnessing of CRISPR, while research and development around genetic modification started as far back as the 1980s. And because of this, gene-edited foods really haven't yet been produced to the extent that genetically modified ones have. But we may see more of them in the future. Whether they will follow the path of GMOs and mainly play a role in commodity crop production, or whether production efforts will have a different focus, maybe focusing more directly on solving nutritional issues or reducing agricultural carbon emissions, is a matter of debate. What do you think will happen? Stay tuned for my next video to find out more.